Hi, so we're going to now simplify radicals and we're going to use these perfect squares to do that. So when you're simplifying radicals, it's also called reducing radicals. We want to get all of our perfect squares out of there. So we're going to have to do some factoring. So just first reminder of what factoring is. If I had like 15 and I wanted to find the factors of 15, I asked myself what things multiply to be 15, 5, and 3. So 5 and 3 are both factors of 15 because I can divide 15 by 5 and I can divide it by 3. So we call these factors of 15. So if we had a more complicated number like, let's say 27, we could factor that up and say, oh, okay, that's 9 times 3. And remember, when you factor, you want to break it down as much as you can. So we could factor the 9 to be 3 and 3. So these are all factors of 27. So we want to factor out the perfect square. So if I had something like the square root of, let's say 24, and we want to find the factor of 20, reduce it, we're asking ourselves what perfect squares can we get out of 24 or factor out? When I say get out, I mean what can we factor out? Well, hopefully you're like, oh, well, 4 times 6 is 24. So I could rewrite this as the square root of 4 times the square root of 6. The rules with radicals are we can pull them apart like that. We can also multiply them together, which we will learn later on. So 6 times 4 is 24. So 4 and 6 are both factors of 24. Well, that's great because I can simplify the square root of 4. We know from last class that the square root of 4 is 2. So I can replace the square root of 4 with 2. And that looks better. And then you look at the square root of 6 and you ask yourself, well, is there anything I can factor out of 6? Remember, when we factor, we want to factor out perfect squares. So yes, 6 is 2 times 3, but 2 and 3 are not on our list of perfect squares. I need to factor out a perfect square. I can't divide 6 by 4 and have it end up nice and pretty, or 9. So it's done. So I think of it as leftovers, and we're going to leave it there because I can't go any further with it. We're done. Let's try something like the square root of 72. Hopefully you're thinking, 72 divided by 4. Maybe. But I do know that 72 will be 9 times 8. So we're going to go, I know that from my multiplication charts, the square root of 9 times the square root of 8. Now we go, well, square root of 9, can clean that up, 3. Now you ask yourself, with this under the radical, can I go further with 8? Can I factor something out of 8? And hopefully you're like, yeah, 4 times 2 is 8. So I'm going to rewrite the square root of 8 as the square root of 4 times the square root of 2. Remember in math, when things are next door to one another, it's multiplication. So now I have right now 3 times the square root of 4 times the square root of 2. And we can clean that up because square root of 4, that becomes 2. Now I'm going to put the 2 there to remind myself to multiply by the 2. If I had just 3 and 2, it might look like 32, and that might confuse me. And then square root of 2, I can't go any further with, so I write as the square root of 2. And then, oh, look, hopefully you're like, well, 3 times 2, we can clean that up. 3 times 2 is 6, and the square root of 2, and there's your final answer. Now, interestingly enough, you didn't have to do 9 times 8. There's other factors of 72. Maybe you thought to yourself, oh, well, I know. 72 is 36 times 2. And if you did, then you go, oh, the square root of 36. That's 6. So this becomes 6 square root 2. And yes, it's fewer steps because you thought of a larger number that factored out. But thinking of the smaller number didn't change our answer. A couple extra steps, no problem. Don't stress out about if you get the largest number that factors out. Just find things that factor out, and you can keep going and asking yourself, oh, I can take more out of this, and just keep taking more out of it every single time.